Well, hi everyone, this is Bob the Science Guy, and welcome to the coverage of the September 2024 partial lunar eclipse. Now, just to kind of orient you a little bit, the main image there is from the RASA 11, which is the main instrument in the Shamrock Banks Observatory. That is an 11-inch Roe Ackerman-Smith astrograph, and up in the upper right corner, you'll see the progression of the eclipse in an insert. As you can see, we're in the penumbral phase of the eclipse. That round sea that you see on the right side of the moon is the Sea of Crisis, and as you can see, the penumbral bounds are just past that, up to the front rabbit ear, which is the Sea of Fertility. So if you're looking out in that area, you notice that up around 10 or 11 o'clock in the moon, it's starting to get a little bit dark compared to down by 3 or 4 o'clock or 6 o'clock. And that is a partial shadow of the Earth. That is not the umbra, which is the dark shadow of the Earth. That is the gray shadow around the umbra. So tonight, as I said, we're going to have a partial eclipse. It's a beautiful night here at Shamrock Banks Observatory. We do have the dredges out in the lake, which is putting a lot of light out and giving us a little bit of light pollution, but we're getting pretty decent images of the moon, which is nice and high in the sky. So atmosphere is very nice tonight. We don't have too much in the line of shivering. So if you will, go ahead and let me know how the audio is going. Is the music too loud, too soft? Anything else going on tonight? Let's see what we have. Thank you very much for the donation, Judy. That'll go towards equipment for the observatory. Oh, Top Code, sorry to hear about your clouds. You must have bought a new telescope recently, and you'll be cursed with 3 or 4 weeks of clouds afterwards. We do have a beautiful night here in Michigan in the United States, and things are going good. Yep, this is an 11-inch RASA telescope. Okay, Judy thinks the music is a bit loud, so let me turn that down just a hair. And that's okay, we'll drop it down to about right there. That'll just kind of give us a little bit of background so we don't have silence when I'm not talking, and I'm not going to be talking all night. I have homework to do, and I will be working on it. That a little bit better for you, Judy? But you're definitely seeing you're seeing the effects of the shadow on the moon right now. You know, that upper left quadrant is starting to get quite a bit blurred out. You can see the progression of the shadow here in the upper right. That outer ring, the one that's the lowest, is the extent of the shadow, and the inner ring is where the umbra is. Seeing is absolutely fantastic. Now, the areas of the moon that are not in the shadow right now are a tad overexposed. I'm aware of that. I am trying to bring out some of the detail in the shadow. I can tweak it a little bit just to see whether or not maybe I can make that a little more aesthetically pleasing. So what we'll do is we'll just go right on over here and we'll kind of tone that down a little bit. That just makes it look a little harsh. But you can definitely see there's a bit of a shadow there. I like to have it just enough that you can see that the Sea of Tranquility is a little darker than the 3 seas around it. The Sea of, if you look at the moon carefully, and kind of use your imagination a little bit, you can see a bunny sitting there, and it appears to be sitting on its back. The Sea of Crisis is the round sea on the right side of the image. And then behind it you have, or just to the left of it, you have 2 bunny ears. The one nearest the Sea of Crisis is the Sea of Fertility, and the one behind that, a little bit more to the left, is the Sea of Nectar. The dark area at the base of the bunny ears is the Sea of Tranquility, and the snout of the bunny just above it is the Sea of Serenity. And then just kind of going counterclockwise around the moon, you have the Sea of Showers, you have the Ocean of Storms, and then if you look down by the crater Tycho, which is down at about 7 o'clock, pretty obvious, you can see the ray system, a very extensive ray system there. Right above it is the Sea of Clouds, and just to the left of that is the Sea of Moisture. And above both of those, you'll see the Sea of Islands. And basically, the two remaining ones, the Frigid Sea is all the way up at the top, which is where the umbra will be coming in. And also, if you look at those three craters just off to the left of the center, you'll see the Sea of Veils just to the right of it. Or Sea of Veils, geez. I always look at that as like a bridal veil, but that's actually the Sea of Vapors, as opposed to the Sea of Clouds. The only remaining sea is down by the sea, just above the Sea of Clouds and the Sea of Moisture, and that is the sea that is known. Now, there's a number of smaller seas. If you look back over to the Sea of Crisis, right below it, you'll see two small seas forming kind of a line. The one to the right at the top of the line is the Sea of Waves, and below it is the Sea of Foam. So what I do is I use the rabbit and the moon as a way to memorize what the seas are. What's my average proper exposure size, or exposure time on the RASA for the moon? Well, let me show you. Currently we are running, let's see, I'm running 1/1000th of a second, or excuse me, 4 1,000ths of a second, about 1/250th of a second, and I have 0 gain, and I'm also down here a little bit, kind of moved the mid-range right here, where, see in the center? I moved that just a little bit to the right. And again, I'd like to be able to see that the Sea of Tranquility is a hair darker than the seas around it, although the shadow is starting to play a little havoc with that. I don't think the umbra has quite come in yet, but it's very, very close. Well, shoot, if you want to get that 14-inch edge HD, a good home that'll be used, you can send it on over to me. The interesting thing about that is you can literally unscrew the front of the primary mirror, or excuse me, the secondary mirror at the front of the telescope without even taking the telescope apart like I have to. Collimation on that with a Hotech is absolutely a breeze. The 14-inch edge is one that I kind of have my eye on. I'm more of a Ritchie Crayon guy, and I'd rather have one of those. But the 14-inch edge is a very close second. It's very nice because you can buy a Hyperstar system for it and basically turn it into a RASA. Yeah. The RASA is an f2.2. So, you know, to be honest with you, if we didn't have an eclipse today, I would consider this a little overexposed. I would probably go with a 500th of a second. I'm wondering if my polar alignment is just a hair off, because that moon is just kind of creeping up a very little bit. I'm using a lunar tracking rate, which you can see down here. You see where the 4 arrows are with a stop in the middle of it? That's my telescope control, and if you look down in the lower right of that box, you'll see my tracking is set to lunar tracking rate. Yeah, those 14-inch edges are rarer than hound's teeth. It does take a while to get them. I do most of my work with telescopes with an S.net, which is Woodland Hills Telescope and Camera. I talked to Farah and Victor over there. They've really been big supporters of the channel, and I get all of my equipment from them. I don't work with them. I don't get any sort of commissions from them. I do get a kind word from them once in a while, but that's about it. Yeah, I'm using native tracking with the mount tonight. The mount that all this is set up on is a Celestron CGXL, and the mount is very good. I have not I've not polar aligned it, and obviously I'm not tracking right now, which is why the moon is tending to very, very slowly drift up. Looks like we're just about getting ready to have the umbra of the moon kind of kiss that northern limb of the moon right there. So to kind of give you an idea of how the moon is, how we look at the moon. Give me just a second. Let me get over here. So this is the Sea of Crisis, and this is considered the eastern limb of the moon. That is the crater Gemaldi. That's the western. Down here, obviously, where Tycho is the southern pole of the moon, and the northern pole is up here. The way I have this set up right now, I don't think I can show my cursors, but I can use my my markers on SharpCap. So speaking of software, this is obviously SharpCap. This is one of my main imaging platforms when I actually just go out to look at things. This is what's called Nina, and this is what I use. That was an earlier shot of the moon. I use this to run the entire observatory. So for example, I can control the dome from here. The other thing that I can do, assuming this thing's set up right, give me just a second here. There we go. Uh-oh, camera fell off. I've got to go fix that. I don't know why the camera fell off, but it did. So we're going to go and get that all fixed. No, maybe it hasn't. Hang on just a second. Yeah, that works. So you see, here's the top of the telescope, and as you can see, we're looking out at the moon. We are a little bit close to that edge. I think maybe what I'll do is I'll move that over just a little bit. So I'll show you how I do that. So I make Nina small and move this kind of off to the side for a second. Okay, that looks a little better. Let's sync it right there. Gracie found a box. Oh, Gracie, don't be eating that one. Hang on. Gracie, don't eat that box. I need that box. There's the one box that I need. You need the other box. That girl loves to chew on things. Plywood, boxes, soda cans, or soda containers. So we're starting to actually get pretty dark here up at the top of the moon. Don't know if you guys can see that really well, but that is where the umbra is going to be coming in, and let's go see if we can see anything here. Yep, looks like the umbra is just getting ready to touch the top of the moon. Ah, you got a 24-inch, huh? L600. Well, when you're using one of those 24-inch telescopes, they really, you know, you're talking about the weight of a refrigerator. I mean, these things are pretty heavy. Oh, I love Nina. Nina's great. And the vast majority of them are on AZ mounts. You know, you have to think about a German equatorial mount like the Celestron CGXL. That's kind of like a piece of survey equipment. That's like a total station. You know, I mean, it's a very finely machined German engineering stuff. An AZ mount, you know, an alt-az mount, is basically a swivel gun mount. Yeah, the QHY-174 camera works very well for the moon. I'm not using it tonight. I'm using the main instrument on the observatory. You know, the reason I decided to do that is I've been playing with it with the small refractors, but I haven't used the main instrument lately. And I wanted to get the RASA, you know, kind of up and running and see how it was doing. Plus, it's got the bigger camera on it. You know, I mean, it's all basically a trade-off. I just decided to go with the main instrument tonight. But the QHY-174 camera that we just got with the assistance of the benefactors and patrons of the channel is a high-speed camera for planetary and moon and solar work. These cameras are designed primarily for deep sky, and they run around 30 frames per second. And that is an awful lot of data. We're talking 120 megs per image. But the, excuse me a second. Gracie? Hush. Come on. But the planetary camera, the QHY, shoots 174 frames a second. And, you know, 170, 150 frames. It's good for that all day long. And that's just really nice for the sun, really bright objects like the sun and the moon. But we're definitely seeing some eclipse here at the top. Not quite sure if the partial eclipse is in yet. Let me go look at the bigger screen and see if I can see that. No, it says it's not quite touching yet. But the umbra is almost down to the south pole of the moon, which is the bottom. So the umbra, you know, is down to the last eighth of the moon down there. You see how dark it's getting up at the top. It's still pretty bright down at the bottom. That has to do with the fact the shadow's not quite there. Plus you have the crater Tycho with that very bright ray system coming out of it right now. Well, we got a goodly number of people watching. Make sure you share this around a little bit. Stick it on your Facebook pages. And send it out on Instagram and all your other social media. See if we get some people looking at the eclipse with us tonight. So as you can see, the penumbra actually extends all the way around the umbra by about an additional half degree. It's about a full moon width. The umbra itself is 2.6 times the width of the moon. So just imagine a disk 2.6 times as wide as the moon is, kind of sliding over it. Now this is kind of a glancing blow tonight, which means we're only going to get about an 8% coverage, but it's still not too bad. Oh, I still call it North and South Pole. And don't ask me about Pluto. I acknowledge it's not really a planet, but I grew up with it being a planet, so it's still a planet to me. You know, it's weird. When that all came down, you know, it was down to about 60 people that made that decision, you know, that voted on it. And I do understand the Earth is wider than that, but the shadow of the Earth at the distance of the moon is only 2.6 times the diameter of the moon. The Earth itself is 3.6 times the diameter of the moon, and that was discovered by Aristarchus in about 200 BC. But what happened was, first they got rid of Pluto, and then Pluto came back, but they decided they were going to include all other Pluto planets. So for a couple of weeks there, we had 14 planets in the solar system, including Ceres and Chiron and several others. But yeah, bite me, rodent. It's a planet to me, but I acknowledge the fact that it is a near Kuiper Belt object. It is a planetoid. It's it is a planetoid, a dwarf planet, I think, is the official name of it. And surprisingly, it's actually about the same size as the moon. Now, here's an interesting fact about the moon. Do you realize the density of the moon is about 0.6 that of Earth? Anybody have any thoughts as to why that would be? Go ahead and put your comments, put your comments up and tell me why you think the moon is less dense than the Earth is. Well, we know it's less dense than the Earth is. Tell me why you think that is. Yeah, Pluto, we hardly knew you. What year was Pluto discovered? Anybody know? Yeah, the very center between Pluto and Chiron is outside of Pluto. Okay, Park, that makes a good sense. Yeah, we'll move that image down just a hair. Let me fix that real quick. My apologies. That a little better? Okay. Yeah, Pluto was discovered in January, between January and May of 1930, out of the Lowell Observatory. I believe that's in New Mexico, by a guy very much like me, a self-trained astronomer that was hired basically for a summer internship and given some busy work to find Planet X. And what he would do is he would take images like I do. He used a slightly different technique. I take 42-minute images, and then the computer looks for anything that moves. He took like 5-minute images, 15 minutes, or and he took longer images a day or two apart, and then put them on a stereoscope and looked for objects that flipped back and forth as he moved the mirror from the left to the right. Very, very tedious, very time-consuming. He looked at plates for over a year until he found an object that was in the right position and had the right orbital period. Yeah, it was 1930. Okay. So, did we figure out why the moon is less dense besides the fact it's made out of cheese and has holes in it? Well, right at the beginning of the solar system, not long after the formation of the planets, Earth actually took a hit from a planet that was something on the order of Mars in size. About a half to 3/4 the size of Earth. And what happened was the mass of both planets kind of that's exactly right, Roden. The mass of, both planets intertwined. Some of it's here on Earth, and some of Earth and that planet became the moon. But the layers that were shaved off from that collision were primarily from the crust. They didn't involve the core of the Earth, which is iron. And most of our density in Earth is towards the core, because the most dense matter on Earth, migrated gravitationally towards the core. So what they did was they chopped off the crust, and a lot of crustal elements went into the formation of the moon, and as a result, it's less dense than the Earth overall. Yeah, basically the moon's made out of Earth crust and crust of this other planet, and I'm sorry, but my game is kind of weak tonight. I can't remember the name of the planet. It has a name, but I just can't think of it right off the top of my head. Theon or something or other like that. Oh, and you're not going to see a Plutonian year since discovery either, because a Plutonian year, I think, is 235 years long. Well, Matthew, the inner planets are primarily rocky and the outer planets are primarily gaseous. So if we were on the other side of Saturn, we should have probably become a gas giant. At least that's my thought. No, it's not Nibiru. Yeah, it was Neptune that got a major whack that, tilted its axis 90 degrees and made it spin backwards or some crap. Matthew's being a smart aleck. The first real conspiracy theory that I heard of that people were actually taking seriously was something called Nibiru, or Planet X, that was supposed to be some sort of a dark planet that was, very close to Earth in its orbit, that just was undiscovered. And they attached all sorts of interesting things to it. Yeah, but that was the first time I remember I was sitting in clinic over by Lake Huron, and my practice manager was there running the clinic with me, and she was talking to me about it, that she had heard some stuff, and I just kind of looked at her and I said, "What?" Okay. She wasn't a believer in it, but she had heard about it and was wondering if I had ever heard of it. So I looked into it a little bit. It was kind of interesting. It's a more interesting story without the really stupid aspects that you see in things like Tartaria. But, stupid, easily provable things. Oh, yeah, if they describe Venus as a comet, okay, well, good for them. And I'm glad you mentioned comets, too, because depending on how late we're up tonight, we may go see if we can have a look at a comet or two. But yeah, Andromeda was supposed to be a nebula, too. But, it wasn't until the 20th century that we really knew that Andromeda was an actual galaxy versus a nebula. Yeah, don't look into Tartaria. It is a Thella. Thella. Thank you very much, Judy. Yeah, I was thinking Theos or something or other like that, but it's Thella. Judy just looked it up for us. Thank you, Judy. Yeah, most of my reports to the Minor Planet Center that make it into the daily orbital updates and stuff like that, you know, the ones that they really like are my observations of the orbits of comets. And I've had 25 or 30 of those that made the papers, so to say. I have heard of Nemesis, and there is actually an asteroid named Nemesis as well. Oh, Matthew, I'm sorry we're going to lose you, man. Have a great night. If you get a chance, hop on your phone once in a while. Maybe pick up the comet later. Am I also keeping track of solar activity? No, I'm observing solar activity, but I don't have anybody. I actually report asteroids and comets to the Minor Planet Center. I don't have anybody that I report solar stuff to. And my equipment is good, but my solar equipment is not scientific equipment like my sky survey equipment is. So, you know, I had a choice, and I actually just kind of made a call. If you look at the equipment that I actually have, I have two types of cameras. I have a ZWO 6200 and I have a ZWO 533. C2023A3, the one that's supposed to be closest to us on October 16th and be a naked eye comet. So basically, I have two cameras. The 533 is a square format camera, and it's just a really good one. It doesn't have any amp glow. It's just a fine camera. And the 6200 is kind of like its daddy, or its big brother. It has 6 times the sensor resolution. So the 6200 covers 3 degrees by 2 degrees of the night sky. So, I mean, it's pretty impressive. And I use that for asteroid surveys. Now, the scientific work I do, I use monochrome cameras with. But I also have a duplicate 6200 and 5330, or 533, that are color cameras. And I use the color cameras for nebula. I can, with the 6200, for example, on a color camera, I can get down, I can push magnitude 19.5. Yeah, is it next to the sun right now? Yeah, it's probably going to come out. I was going to check and see if it was going to be available. But the 6200 color camera, I can push magnitude 19.5. With the black and white camera, I get 4 times the resolution, and I can hit magnitude 20.5. And that's in Bortle 3 sky, or Bortle 4 skies. So, I mean, I'm really at the limits of what my skies will allow me to get with that camera. Now, when it came to solar and lunar astrophotography, I did get a planetary camera that's color, and that is the QHY 173. It is a color camera. It is not as precise as a monochrome as far as the fine details, but the images look very much better, and I got that primarily for outreach. You know, I basically wanted to make sure that people had really interesting things to look at. We're starting to get an awful lot of darkness up here. So that, you know, we've kind of lost, come on. So we've kind of lost that north side of the moon. I mean, it's gone. So if you look carefully at the eclipse data up in the upper right corner, you'll see that the umbra of the Earth is actually hitting very near where the crosshairs are. So it's hitting just north of the frigid sea. And that's, as you see, we've lost all detail of the moon up there. And the entire moon technically is in the is in the penumbra right now, except for that one little corner up there at the North Pole. Yeah, so it's coming around. It's coming around the sun right now. So we're, I've obviously looked at it quite a few times, and I've measured it. I've been measuring it for the last couple of months. C2021 A3 is another one that I've been following pretty closely. But yeah, I did some of the orbital updates for that. This is pretty cool stuff, isn't it? Make sure you hit those likes, guys, and share it around a little bit. Yeah, we have a supermoon tonight, which means the moon is very close to perigee. It's about 90% perigee right now, so it's larger than normal. And this is a special full moon. It's called the harvest moon. Now here's an interesting question for you. Why is it not a blue moon? What is a blue moon? And where does the expression once in a blue moon come from? Yeah, those comets tend to dive into the sun. That was an interesting story too on asteroids. The first asteroid discovered, of course, was Ceres, which was discovered in 1800. But they ran into a problem rather quickly. They spent an awful lot of time tracking it, and then it went into day. Correct. Paper Park. It is the second full moon of the same month, and we haven't had two full moons this time. Matthew, thank you very much for the donation. That will go towards cat treats, and it will go towards equipment for the observatory. I don't take any profit from any of the channels. This one, Bob the Science Guy, anything. And, of course, I do generate income with that. But all of that income goes directly into equipment for the channel, video equipment, things like that to make things better. That's not a photo, Mr. B. That's a live shot. This is through my telescope in the backyard, through the observatory. Yep. I have 3 dogs and 2 cats. I think I'm going to be down to 1 cat here pretty quick. I do make it a big point to say goodbye to little Missy every day when I go into class or whatever. Pretty sure she was recently, she's more than likely got cancer, and is getting a lot of ascites in her belly right now, and is just starting to slow down quite a bit, which is unfortunate. I don't think there's much that can be done. But she had a really good 4 years with us, and she's comfortable, so we're going to leave her at that. Otis, on the other hand, is just living his best life. Okay, so you can see a pretty hard line between the umbra and the penumbra. Let's go see if we can tease that out a little bit. Yeah, Otis, the orange cat, is the astronomy cat. And, okay, so when you increase the exposure a little bit, you can definitely see that penumbra. Or you can definitely see the umbra, but you cannot see the penumbra. And as you can tell, it's coming in on the frigid sea up here at the top. So what I did was I just changed the light curve a little bit. And as you can tell, the southern part of the moon is obviously washed out, but we're getting a nice hard demarcation between the umbra and not umbra. So that's most definitely an eclipse there. I gotta go plug this bad boy into the power before I lose this. Hang on just a second. There we go. Yeah, Mountain Dew, my favorite. All right, guys, you be good. Saying goodbye to the dogs real quick. Hey, Missy. How you feeling, girl? You know, this brings up a very important thing about astronomy. Most of your images are kind of a trade-off. You know, this is a good example here. If you want to see details on the moon, it's kind of difficult to tell the difference between the umbra and the penumbra. But if you bring up the exposure enough to see that demarcation there, you lose the details on the moon. Trying to work out a happy medium here. Another example of this would be the moons of Jupiter. If you set your exposure to see the moons of Jupiter, you can't see, you know, Jupiter's just a blurry, white, glary disk. If you set it so you can see the atmospheric bands on Jupiter, you can't see the moons anymore. So let's go change this around to here. So there's the shadow of the Earth right there. That's no bueno. Let's drop it from 10 milliseconds down to about 4 milliseconds. Try this again. Yeah, a little bit better. You still see an awful lot of glare from the southern part of the moon. And the top part's just not real distinct. See, I'm just kind of adjusting it. Got to come all the way down here, and I'm still got a little bit, still pretty washed out here by Tycho. Let's see if we can bring that out a little bit better. Let's drop it down to about a 3-second. Let's change this also over to Fitz Images. So you see, I've got to come all the way down here in order to not blow out Tycho. See, there's the shadow of the Earth. Notice it's curved. All right, let's leave it about like that. The contrast in brightness between the North Pole of the Moon and the South Pole of the Moon is just too much to really... It's exceeding the dynamic range of the camera. But it's still not looking too bad. What do you guys think? ISO setting. Well, there's not really an ISO setting on a digital camera. I've got 0 gain on this right now. Newtonian telescopes must be sized so a can't squeeze through the secondary spider. That's very true. For those of you that don't know, I have Otis the astronomy cat, who is a typical orange cat, and he exhibits orange cat behavior. He came to us via the cat distribution center, and then a year or so later he brought us a kitten, and that became Missy. But someday maybe they might paper park. You can always, you know, the interesting thing, when you look through a telescope, you can see the moons and the bands on Jupiter because your eyes can see that. You can't really get a camera to do it. The gain on this is almost zero. Now, I was getting ready to say something. Oh yeah, Otis. One of Otis's favorite tricks is he learned how to get into the observatory by crawling under it and coming up through the hole in the floor where the pier comes up. You know, the pier is mounted directly into concrete in the ground, and the deck of the observatory actually has a hole in it around the pier, so nothing touches the pier. And the other thing that's interesting about my pier is I filled it with sand to dampen vibrations. But the ISO on this, again, we don't really have ISO on a digital camera, but the gain on this is zero. It's set to zero right now. We can play with that a little bit. So unity gain for this telescope, or for this camera, is 102. So let's go over to that. So here's 102. So that's unity gain. And then what we can try and do maybe is decrease the exposure a little bit. A little bit. You know, you can still see some detail down here, but the shadow itself is very indistinct. You know, that's a distinct shadow there. But that's the partial eclipse of the moon. So you can definitely see that this area of the moon right up here is eclipsed. So that's all eclipsed up there, and it came in exactly where NASA said it would, which is just north of the Frigid Sea, and it's actually following the path as expected. Now let's see this real quick. And that's pretty much, I think, we should be approaching total. Yeah, it's 10:39 p.m. and maximum eclipse was listed as 10:41 p.m. Yeah. Oh, Mr. B, that's good. You ever see that one cartoon, the astronomers cartoon? They had two astronomers. One had a Smith-Cassegrain and the other had a refractor. And they were both looking at this castle, and the guy in the refractor says, "Look, there's a vampire." And the guy in the SCT said, "I don't see anything." You're outside. What's the planet next to the moon? Hell, I don't know. We can find out, though. I believe it's Saturn, to be honest with you. Give it a second. Wait for it. Wait for it. Well, let's follow that. That would be Saturn. I heard Saturn was going to be close to the moon. Now, if you actually look at the moon right now, come on. Look at that. It even shows the partial eclipse. And who says stellarium isn't accurate? I know, you want to take a break for just a second, go see if we can see Saturn? We can do that. Oh, give me a second. Okay. So let's go back over here. Let's turn this off. Now, where the hell are we? See, the telescope in the dome didn't move very much. Now, because my exposure is so short, I can't see anything. I think we can fix that. So that's at 102. Okay, we're getting some data. See if there's enough data here to be able to plate solve. Yep, it plate solved. It was 1.1 degrees off. I plate solved, and then it slewed right to Saturn. So, this is not a telescope to look at planets with. It doesn't have enough focal length. It's only got 620 millimeters of focal length. So there's one of the moons of Saturn. That's Titan that you saw there. So that's definitely Saturn. But as you can tell, this is, really the wrong telescope to look at Saturn with. Okay, oh. Just kind of teasing it here a little bit. Yeah, so that's definitely Saturn. We've been looking at the moon for quite a while. Let's look at one other thing here real quick. You guys want to play around just for a minute? Or do you want to go back to the moon? Let me know in the chat if you want to play around for a couple minutes. You want to go back and look at the moon again. Okay, so we're connected to this program, which is called SkyTrack. I'm thinking we should be able to hit this nicely because it wasn't that far of a jump. Let's go on up here to half a second. Right to there. What do you think those are? So these are stars. What are these guys right here in the center of the screen? Right in there. Yeah, the rings are close to edge on. They are visible. You know, you have a choice when you start off in astronomy. You can look at planets or you can look at everything else. You need a big telescope to look at planets. Okay? You need a lot of focal length and you need a lot of light. Even though they're very bright and they're close, they're also very small compared to something like the California Nebula or the Orion Nebula. Those are geostationary satellites. There are 3 of them right there. There's a 4th one over here. Here, I'll show you where the 4th one is. It's towards the right of the screen. So, these are the main satellites. There's another one right here. Right there at the crosshairs. So again, these are moving against the background of the stars because they are staying at a very particular spot directly over the Earth, right here over the Amazon jungle. You can see it right at the center. You see this kind of squarish green extent of visibility. If you look on Brazil, you'll see a small blue dot there. Now, if you look up towards Michigan in the United States, you'll see a red dot. That's my location. And actually, if we zoom this out a little bit more, you're going to have to look a lot careful. You're going to have to look very careful. As a matter of fact, we're probably going to have to increase this up. Let's put it at 2 seconds for right now. So if you look very carefully at the center of the screen, you'll see those 3 satellites. Let's zoom it in just a little bit. So you see the 3 satellites right here? Okay, there's 3 satellites there. There's a 4th one right there. There's a 5th one right there. And there's a 6th one right there. So I'm going to turn this off. Now look very carefully. Right in that region, you'll see 3 satellites in a row. This is probably a GPS satellite coming in from the bottom. The reason I say it's a GPS satellite is that it's moving faster than the geostationary satellites, but it's not moving that fast. That streak is relatively short. Low Earth orbit satellites haul ass. They will be halfway across this screen with each frame. So geostationary satellites orbit the Earth over the equator once every 24 hours. GPS satellites are at an angle to the equator and they orbit the Earth every 12 hours. But that's another satellite going by. So people that say that you can't see satellites, you sure can. They're all over the place. I'm not saying you can't see them, Paper Park. SCTs have got a lot of focal length, 2500 to 3500 or more. And they are really good at magnifying things and filling the screen with planets. The problem that you run into with that is you can see the core of the Orion Nebula, but you can't see the extent of the Orion Nebula. You can't see the extent of large objects, and there's a lot of very large objects up in the sky. The field of view in a high focal length telescope like an SCT is very, very tight. You know, like I said, you're looking at 1/4 of a degree by 1/4 of a degree, perhaps. I'm looking at 3 by 2 degrees. So yes, you can see them, but you can't see all of them, and you have to use a technique sometimes called mosaic, where you take a series of pictures and stitch them together because, you know, as the guy from NASA likes to say, we had to. Yeah, so those are satellites. As a matter of fact, I think there's a couple more over here. Let me look again. Yep, there's another one right there. I didn't see that one earlier. Let me show you what I'm talking about. So you see this group right here. There's another one right there. That's like 8 satellites that we've got tonight. Well, normally this has a group of 4 with it. I'm wondering if that might be the 4th one. It just wandered off a little bit, because I only distinctly see 3 of them here. And then there's 3 in trail. So you see the stars are streaked because, you know, the telescope is locked on these, and as a result the stars are doing their own thing. There's the 4th one right there. You guys don't see my my cursor, do you? But basically you're looking at a VW microbus, if you know what one of those are. You know, a small van, like a minivan, that's 40,000 kilometers away. Let me give you the range to those right now. Give me a second. That's 38,250 kilometers from me and 36,000 kilometers in altitude. So we're slewing the telescope to a different target. You see the telescope goes first, then the dome's coming around to try and catch up. Seems to pause before its final you know, little push. Okay, let me just tweak this a little bit. So what we'll do is we'll turn off dome sync. That looks lined up pretty well. Let's see if we can take a picture of this and figure out what we're looking at. Okay, so the camera knows what it's looking at now, and it also knows what I told it to look at, and it says what I told it to do is 1.35 degrees away. So it's going to move over to where I told it to be in the first place, and there it is. Now we're going to do something a little different. We're going to go ahead and start guiding. So what I've done is I've locked on a star here, and this software right here, what it'll do is it'll keep the crosshairs right on that star. So this is the mount guides nicely, but it's only good for about a 30 to a 60 second exposure. With guiding like this, I can shoot 5 minutes. We won't do that, but okay, let's go on to the next little thing here. Now bear with me, I'm going to go ahead and take a 2-minute exposure here. So, astronomy is a game of patience, my friends. And we're going to do a little patience. So here's the guiding down on this lower graph, and my guiding is to just over 1 arc second right now. Again, like I said, I think it's just slightly out of polar alignment, which is why it's above 1 arc second, but that's still pretty accurate. So let's go back to the chat for a minute and see what's been cooking here. I've been kind of ignoring you guys. Say a couple of hours ago the moon was occulting Saturn. Yeah, I'd accept that. Paper Park, is that Professor Parks? The rings are very close to edge on right now of Saturn. They're very close to edge on, but they're not quite there. Yeah, and they're definitely still visible. I'll see if Orion's around. Yeah, no cursor. Sorry about that, guys. Okay. Almost showtime. Now, what you see down at the bottom here is red, green, and blue and luminance color curves. Notice that they're scattered all over. If I do that, they all line up on top of each other, and that's called white balancing. Now the next thing that we want to do is we want to get our dark line right to the peak here, and we want this curve to kind of intersect this line right where it changes from a really steep slope down to a more gentle slope. So let's go ahead and do that. And that, ladies and gentlemen, is why we do astronomy. This is the Andromeda galaxy. That's the core, of course. You can see those dark dust lanes. That is M32, and M110 I think is up here, isn't it? There's M110. Those are 3 galaxies in one image. Probably 40 or 50 civilizations looking back at us right now. But you see, again, look how far I have to bring this out to get all of these, get this whole thing in. Now, with a Schmidt-Cassegrain, you may be able to see just right around the core here. You're not going to see the entire galaxy like that. There's just too much focal length to it. This red that I'm getting could be caused by a couple of different things. One is there could be some smoke up in the air. I don't know how our fires are doing right now, but you know, you kind of see reddish gold when there's smoke in the air. The other thing is that I've got dredges out on the lake right now, and they have very, very bright banks of floodlights so that they can see what they're doing as they dredge the lake. And that throws a huge amount of light pollution in the area. Plus, it's a full moon. So we're kind of struggling here a little bit. I may be able to just kind of tune a little bit of that red out. Can't do it with that one. Let's see. Well, didn't like that too much either. That's a galaxy. That's 3 galaxies actually. I just was wondering if Paper Park was Dr. Parks. Now, as you can see by this little diagram up in the upper right, the sliver of the moon that is eclipsed right now is getting a little smaller. So we saw maximum at about 10:41 about 25 minutes ago, 24 minutes ago, and now it's starting to kind of come out of the umbra again. So I think we're pretty well done with the lunar eclipse. And to be honest with you, I've got to get some homework done tonight. We have exams this week. So I'm gonna go start playing around with that. I've got physics this term. Got a test in calculus 2 on Thursday. And linear algebra, I've got a test by Friday. So I've got my hands full. I'm in my math year right now. Next year I start some of my other majors. Math is actually a minor, but it's a prerequisite for a lot of the classes I need for my major, which is astrophysics and astronomy. So I'm getting my math and some of the basic work out of the way right now. That's what I've been working on this year. But in any event, that's Andromeda, M31. It's also M32 and M110. Thank you all very much for swinging by. Yeah, I'm going to work a little bit more on the homework. I want to do vectors and such this week. I've been kind of busy because, like I said, I've got to, my priority is the exams. But I do want to do vectors, and then we're going to do kinematics. So it should be fun. Well, good night, folks. Thank you all very much for stopping by. If you haven't subscribed to the channel, please do so. Hit a couple of likes so the next time I come up, at least it gets pushed out a little bit. If anybody's interested in subscribing to the channel or becoming a patron of the observatory, the links are right in the description.